Hi guys, welcome back. So in this video, we'll quickly go through some statistics and probability, the very basics of it, before we move on to other data science and machine learning models. So this is going to be very quick and it's going to be very simple. This is not comprehensive probability and statistics. We'll slowly move on to comprehensive probability and stats in the later videos, but here I just want to clear out the basics of it. So in stats, let's start with what the population is. So the population is basically the set of all possible observations in a given context of a problem. So in this case, our problem could be something like, find the total number of population in a particular city, or the number of people that there are in a city. Find the population of the city. So every single person who lives in that city forms the population of it. Now, a sample is a subset of observations from a population. So let's say that this is one city, city A, and there are people inside, right? Like people live in the city. Now, a small percentage of these people would form a sample, all right? Now, this sample could be decided by whatever way you want. You could decide the sample by a particular gender of people or people above a particular height. But since the sample comes from this population, it's a sample of this population. Okay. So now, why is finding a sample important? Because let's take an example where we need to find the population of a country. Okay, now this is an extremely arduous task because there are so many people in a country. You can't possibly go to each and every household and count how many people there are. So what you do is you take samples from different cities and different villages or towns, and based on the demographic, based on gender, and then you try to estimate the total number of people there are in the country, the total population of the country. So that's why finding a correct sample from a population is very important, because we need to estimate parameters. What is the mean age of the country? What is the range of the ages of the people of a country? How many people there are in the country? So that's why finding a sample is very important. Now let's move on to the measures of central tendency. They help us summarize and comprehend our data very well. So the first measure of central tendency is the mean, which is nothing but the average, the aggregate, the summation divided by the sum of all observations divided by the total number of observations. So this here is the formula of a mean. In simple words, the mean is just the center of gravity of a data set or data points. So let's say I have a data set like this where all the points are clustered close by. So the mean would be somewhere over here in the center. It gives you the point where you can find the center of gravity. This is basically the aggregate, right? But now you have to be careful about the mean, because you can have, suppose if I have a data point very far away from this cluster of data points, somewhere around here, then it is possible that the mean can shift away from this cluster of data points into somewhere over here, right? This could become the new mean. And because the mean is just the arithmetic aggregate, this is bad, because this would give us a false idea about our population. If we are trying to estimate the population parameter from the sample, which is this, it could be bad because it would give us a false perception of our population, right? There's a very funny joke in stat which goes along the lines of, if your head is in the freezer and your legs are in the oven, you might be dead, but the mean temperature would be normal. So that's why mean is not a very good, I mean, it is good, it's used in a lot of places, but you have to be careful when you use the mean. You have to make sure that you don't have a lot of outliers in your data set. This point over here would be called an outlier. Okay, so there are ways to navigate through outliers and remove them, and we discuss them in one of the later videos. So one of the properties of mean is that the summation of the deviation around the mean around points is 0, all right? So if I have the mean given by x bar and I have data points I equals 1 to n data points, and I subtract them from the mean, the summation of them would always come up to 0. This is a property of the mean. So every point around the mean subtracted and then summed together would give us the value 0. And with the mean, there's also very nice phenomena that's related to the mean, which is called the wisdom of crowd, CROWD. The wisdom of crowd is a phenomena that basically states that the collective knowledge is better than the individual knowledge, all right? To give you an example, there was a study conducted in a village of 800 people in the United Kingdom, where the villagers were asked to guess the weight of a bull, and the person who was closer to the actual weight of the bull would be given a prize. And everyone gave their guesses, and it so turned out that the mean of all of the people's guesses was better than the answer given by the person who won the prize, right? So that is what you call the wisdom of crowd, and this phenomena is generally observed everywhere in 99.9% of the places where you use the mean. And so now moving on from the mean, we have the median. Okay, so the median is the value that divides the data into two equal parts, okay, at the 50% mark. So if I have data points x1, x2, x3, x4, x5, if I have this data set like this, and these are sorted in ascending order, the median would be x3 because it's the data point that divides the data set into equal halves, right? And if I have x6 over here, then the mean would basically be the average of x3 and x4. Sorry, the median would be the average of x3 and x4 if I add another data point here. So why is the median good? Is because it's, like I said, you know, if you take this example over here on top, the median is resistant to outliers. Even if you have one or two outliers over here, you might have a second outlier here, the third outlier over here. But it doesn't matter. The median would be close by in the group, and it would help you estimate the population parameters better. So that's why the median is good for all practical purposes, right? Now moving on to the next one, we have the mode. The mode is nothing but the most frequently occurring value in the data set. If I have a data set with x1, x2, 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 x1, x3, x4, x5, the mode would be x2 because it's the most frequently occurring value in the data set. And then we have the percentile, quartile, and decile. So the percentile, quartile, and decile are used to basically identify the position of a data point in a data set. So if I want to find the data point which comes in the 5th percentile of the data set, I would basically replace this value x with 5, okay? And so the formula would become 5, which is into n. N is the total number of observations in the data set, plus 1 by 100. So whatever value you get here, that value rounded down to the lowest, to its lower value will be the percentile, will be the value that gives you the percentile. So suppose I get something like 5.1 over here. So this rounded off to the lower value is 5, which means that the 5th data point in our data set is the 5th percentile, okay? Now, the difference between percentile, quartile, and decile is that percentile can vary in, so if I take the percentile, it can basically be anything between 0 to 100. It can take on any real values. I can find the 5th percentile, I can find the percentile that forms 6.9 or 7.1 or 8.2, anything, or 20.9. Quartile are only calculated in quarterly intervals, okay? So that includes 25th, 50th, 75th, percentiles. So basically, the 25th, 50th, and 75th percentiles are quartiles. The decile is all in multiples of 10. So you have the 10th percentile, 20th percentile, all the way to 100. This forms the decile, all right? So percentiles are basically used to identify the position of a data point in a data set, and are used very often in education when you have to find the rank of a person in a group of individuals that gave a particular test. So if you want to find everyone who was better than 90% of the people, you would find the 90th percentile. So this would be 90 into n plus 1, where n is the total number of observations whole upon 100. Okay. So now moving on to the measures of variation. The measures of variation also help you find the characteristics of your data set. The first one is the range. The range is very simple. It's just the difference between the maximum and the minimum value in your data set. So yeah, that's it. That's what the range is. The range is the maximum value minus the minimum value. It basically tells you how large in magnitude your data set is. Next, we have the interquartile range. So the interquartile range in a data set is the difference between the third quartile and the first quartile. This is basically just P75, the 75th percentile, minus the 25th percentile. The first quartile is the 25th percentile, and the third quartile is the 75th percentile. So the interquartile range is just Q3 minus Q1, which is the 75th percentile, which is the magnitude of the value that comes at the 75th percentile, minus the magnitude of the value that comes at the 25th percentile. So now interquartile range is used to find outliers and remove them from your data set. We discussed over here how outliers can affect the mean of a data set, right? So interquartile range is actually used to remove outliers from a data set. How do you do that? Is you find the interquartile range, which is Q3 minus Q1. You find the interquartile range, you subtract 1.5 times the magnitude of the interquartile range from the first quartile. Okay, so you get the lower bound of what you want to consider in your data set. And for the upper bound, you add 1.5 times the interquartile range to your third quartile, which is the 75th percentile, right? This gives you the upper bound of your data set, and this gives you the lower bound of the data set. Okay, so this is the upper bound, and this is the lower bound. So every point that lies beyond this range, and this range, right, is discarded. It is considered an outlier and it is thrown away. So you can use the interquartile range to find outliers. Now let's move on to variance, which is one of the most important measures of variability. So the variance is very common. It's used heavily in lots of applications, from machine learning to finance to quantitative operations, everything. So the variance is basically used to measure the variability of the data points from the mean. It basically shows how spread out your data is. So if I have a data set, I get to know how spread around the mean my data set is. So the mean is given by xi minus x bar. So I'm sorry, the variance is given by xi minus x bar. X bar over here is the mean, all right? This is the mean, and xi is all the data points from I equals 1 to n. So you subtract the mean from all the data points, you square them, you add them, and then you divide it by the total number of data points. This is the total number of data points. Okay. This gives you the variance of a data set, which helps you measure the spread of a data set. Now, this is the formula for the variance of a population. What happens if you want to find the variance of a sample? In that case, the difference is only very small. All you do is you change this n to n minus 1. Now this n minus 1 is called the Bessel's correction, Bessel, correction. Okay, so the Bessel's correction is added only when you're calculating the variance from a sample, not when you're doing it from a population. You need to remember this difference. Right, now why is it done so? Now there are two arguments to why it's done so. The first one is that Bessel found out that when you try to estimate a parameter like a variance from a sample, you tend to underestimate the variance, all right? So so you tend to underestimate the variance. Underestimate the variance. Okay? You tend to find a variance that's much smaller than the population variance. He came to this conclusion after performing a lot of experiments. So to account for that, to account for the underestimation and to get the sample variance as close to the population as possible, we divide by n minus 1 instead of n. The second argument to this is from the idea of degrees of freedom, where the degrees of freedom is given by n minus k, where n is the total number of points in the data set and k is the total number of parameters that you're trying to estimate. Okay, so k is, in this case it's 1 because we're just trying to estimate one parameter, which is the variance. If you're trying to estimate 2 or 3 parameters from a single sample, then k would be equal to 3. So you would have n minus 3 instead of n minus 1. So these are two arguments as to why you need the Bessel's correction for finding the variance from a sample of a data set. Now let's go into the standard deviation. Standard deviation again is simple. It's just the square root of the variance that we saw over here. Okay. And it tells you how much a data point deviates from the mean. There's a difference between standard deviation and variance. Variance tells you the spread in a data set. Standard deviation tells you how much a data point deviates from the mean. Okay, so this is your variance and standard deviation. Now I want to stop here and I want to bring about a very important idea in statistics, which is the Chebyshev's theorem. Okay, we can make use of the mean, variance, and standard deviation and put them together in the Chebyshev's theorem. The Chebyshev's theorem basically is an empirical rule that allows us to identify the proportion of observations that is likely to lie in an interval defined by the mean and the standard deviation. Now I know this definition looks heavy, but I'll explain this to you with an example. Okay, so this is how the formula goes. The proportion is given by mu minus k sigma, where mu is the mean and sigma is the standard deviation. Okay, and k is a constant, and the proportion will always be greater than equal to 1 minus 1 by k square. So to explain this to you with an example, let's say I am a bank and I have 12,000 on a daily basis. I have 12,000 people who use the credit card, all right? And the standard deviation, on a daily basis, I have the mean around equal to 12,000 because on average, 12,000 people use the credit card every day. And the standard deviation is about 2,000. So this mean varies by 2,000. Okay. So I want to see the range in which the users would fall. Okay, the proportion of users that would use the my credit card on a particular day. So the formula is given by proportion is equal to mu minus k sigma, where sigma again is the standard deviation, and this is less than x, this is less than equal to mu plus k sigma. Okay, so over here mu, as we all know, is 12,000 minus k. Now k is a constant here, right? We want to find how many people would Okay, so yeah, so the mean here is mu and the standard deviation is 2000. And I want to find the proportion of people that spend between 8,000 and 60,000 dollars on a single day. Okay, so the proportion that I want to find is between 8,000 and 16,000. Okay, so how would I do that is I would take mu, which is 12,000. I just write it here, 12,000 minus k into sigma. So the lower bound is 8,000. So what will I multiply to the standard deviation to make it 8,000 is 2. 2 into 2,000 less than x less than equal to mu plus 12,000 plus 2 into 2,000. This gives us the upper range and this gives us the lower range. Okay, so this is basically 8,000 and 16,000. So I want to find the proportion of users proportion of users between 8,000 and 16,000 dollars, and that is equal to 1 minus 1 by k square. Okay, so here we saw that k over here was 2, so this comes out to be 1 minus 1 by 2 square, which is equal to 0.75. So from this we can find out that about 75% of the population would spend between 8,000 and 60,000 dollars. Okay, so this is the Chebyshev's theorem. So now let's move on to probability. Yeah, so now in probability, let's start with the definition of a random experiment. A random experiment is one where the outcome is not known with certainty. So this, for example, we can take spinning a die as a random experiment. So when we spin a die or roll a die, we don't know for sure what number is going to come on the dice. It can be anything between 1 to 6, right? So we do not know the outcome of this experiment with certainty. So that is a random experiment. A sample space is a universal set that contains all the possible outcomes of an experiment. Now, taking the same previous example where we roll a die, a sample space for rolling a die would be all the numbers, all the values that the outcome can take. So when you roll a die, you can get any number between 1 to 6 inclusive, right? So that is basically the sample space of our random experiment. And then we take an event. An event is a subset of a sample space, and the probability is calculated with respect to an event. Okay, so I can take an event such as, what is the probability that I get a number less than 3? So in which case we can find the probability by frequency over here. So in our entire sample space, we have just two values that can take a value less than 3, which is 1 and 2. So the total number of values that can take a value less than 3 is 2. And n over here is the total number of outcomes of the experiment possible, which is the length of the sample space. So this is 6. So this is 1 by 3. So then the probability that you get a number less than 3 is 1 by 3. All right. So now let's move on to the fundamental concepts of probability. They're also known as Kolmogorov axioms. So Kolmogorov is basically a Russian mathematician, and he came with his axioms of probability. The first one is that the probability of an event lies between 0 and 1. The probability of a sample space is always equal to 1. And the probability of x or y is equal to probability of x plus probability of y, where x and y are mutually exclusive. Now, using these three axioms, you can derive a lot of other ideas in probability. So some of them are as follows, where you have the probability of a complement of a set is equal to 1 minus the probability of that set. The probability of an empty sample space is always equal to 0, and the probability of A or B is equal to probability of A plus probability of B is probability of A and B, where they're not mutually exclusive. Next, we have the joint probability. So the joint probability between two events A and B in a sample space is given by the total number of observations that fall in the intersection of A and B upon the total number of observations. Okay, now the marginal probability is the probability of an event without any conditions, right? So you have an event where there are no conditions. So again, this you can just find using the frequency that we discussed earlier. You take the number of events that follow your question or the question that you're trying to solve upon the total number of events. And then there are independent events where the occurrence of one event does not depend on another. So let A and B be two events, then the probability of the event is equal to probability of A into probability of B. Now, independent events are events where event A does not depend upon event E. The occurrence of event A does not depend upon event B. So if you want to find the probability of the event where A and B occur, then and A and B are independent of each other, then the probability is just the probability of the individual event A into the individual event B, into the probability of the individual event B, all right? So I'll stop here, and in the next video, we'll cover conditional probability and the Bayes theorem in a little depth. We'll also solve questions to understand how it works. And Bayes theorem is very important in machine learning. I can't stress enough on it. So I'll see you in the next video. See you.